play for just a little bit. Got it. All right, so let's let that be like that. Let me go ahead and start sharing my screen. Hit done, view. What's his last name? Quincy. Come on, what is his name? There he is. We got a full house right here. B. Okay. Okay. All right. I'm going to share my screen. Okay. All right. Oh no. All right. So greetings. Let's see. I hope everyone is doing well. I hope everyone had a great weekend. Let me see, as far as announcements go, so this is College Algebra 2, right? So the main thing for us is that we are basically, hopefully everyone has gained access to Pearson, is able to make their way through the assignments or the homework and quizzes. If you are in need of support, you just have to speak up. Keep in mind that tutors are already included in your tuition, so you've already paid for tutors. I highly, highly recommend that one, you go ahead and seek out the tutors, know their schedules, know how to contact them and reach them. I encourage you to sit down with them and work on this. Also, I do encourage you all to communicate. So like, I don't know if you all have a group meet going or something like that where you all are just, just chat it up, but I encourage it. I think it's a good idea. I've had students using it for years now, and I personally have had good experiences with it. No complaints on my end. As usual, if you have questions, comments, or concerns, feel free to either unmute yourself or type in the chat. So far, that system has been working pretty well. I will check the chat again for stragglers in about 11 minutes, right? So right at about 1:15. And again, the main structure of our course, this is remote, online, asynchronous, which means that all I really expect from each session from you guys is just to get your attendance credit. That's the minimum on a day-to-day. You're not obligated to stay. If you feel like you need to leave for whatever reasons, you don't have to announce it. You can just go and it's okay. These sessions, so far, I have been able to successfully live stream these to my YouTube channel. So it is a good idea to be subscribed to my YouTube channel with your notifications turned on, at least while you're my student. Once the course is over, if you want to stay subscribed but just turn off your notifications, I totally get it. Yeah, I can't really think of anything else. So usually, now let me see. So this is the top of the third week, right? We meet twice a week. So usually what I've done in the past, like on Mondays, I'll go through as much of the lecture as I can. And then on Wednesdays, I'll go through as much of the homework as I can. I want, again, my YouTube presentations, they should have the whole section already done, right? So I took some time to go ahead and create those videos and but hit on everything I wanted to talk about. So that way we can maximize our time during class. Oh, and so the other thing is, so with this being the top of week 3, what that means is next week, and we can expect exam 1, right? So exam 1, you can get max credit for 7 days, right? It should become available this upcoming Sunday at 11 a.m. I think I just threw a little bit of extra time in there. And then it'll be due the following Sunday at 11:59 p.m. going into Monday morning, right? So for those approximately 7 days, you can get up to 100%. Past the due date, you still get unlimited attempts. The system is still set to take your highest score. There's just a 10% late penalty, okay? So I'll check the chat and I'll check Zoom again momentarily in about 10 minutes. But aside from that, let's go ahead and hop into today's material. So let me see. So with this being the top of week 3, I believe it is. I think I'm doing it right. We are going to start chapter 3 on exponential and logarithmic functions. And so we'll start today with section 3.1 exponential functions. So what that means for exam 1, basically, week 1, week 2, and week 3 is what you're responsible for. Another heads up, I think that in order to access exam 1, I created prerequisites where you have to pass the quizzes for weeks 1, 2, and 3. Right, so you have to score at least 70% on quizzes week 1, 2, and 3. The quizzes should only be 5 questions. It should be fairly short, and they're going to more closely resemble your exam, right? So the way the exam is going to be. Also with the exam, you can anticipate unlimited attempts. It's going to take your highest score, but you don't get feedback until you submit your exam. And each time you take the exam, it's going to change. Right, it's going to be a completely different set of questions. It'll be the same content, but it's just not, I'm not shuffling, I mean completely different set of questions. So every time you take the exam, it's going to change. And so the only way you can really maximize your score, you want to have some level of proficiency going into it, Okay. Again, I'll check the chat for questions in a moment, and let's just take a look at some of the objectives for this section. So again, we're going to be looking at section 3.1 exponential functions. And so some objectives are, we like to define an exponential function, graph exponential functions, develop formulas for simple and compound interest, understand the number e, graph the natural exponential function, and model with exponential functions. Okay. Just checking the time. Oh, I lost my slide. Did I really lose my slide? Oh no. Sometimes let me back up and see if I do like this. So I think that sometimes it is on the first. No, not now. Let's try. There we go. Yeah, it was just bugging out. Oh, that's better. Okay. So an exponential function here. Let's do like this. So an exponential function f of the form f of x equals a to the power of x, where a is strictly greater than 0 and not equal to 1, is called an exponential function with base a and exponent x. Its domain is all reals, right? So do I not have that here? I usually have that story, but I guess not. I kind of want to do a story time. Yeah, I'm going to take a moment. Do I really want to do that? I'll save it for later. So what we mean, an exponential function. So in the past, you might be familiar where we have like power functions, things like x squared, 3x to the power of 5 or whatever. But here, what we're going to be looking at is where the variable is now in the exponent. So we have some positive base that's not equal to 1 to some variable x raised to the power of variable x. So with these conditions, that's what we mean for it to be an exponential function with base a and exponent x. Okay. Okay. So in this example, first we want to just take a look at evaluating exponential functions. So with different values of x, with those inputs, what are the corresponding outputs? So for instance, for part A, when x is 4.
Excuse me, Professor Phifer.
Go ahead.
Excuse me, I'm sorry. Can you go back to the last slide real quick?
Yeah.
Okay.
And then
thank you. I'll take a screenshot. Thank you.
Yes, no worries. So I guess I do need to go ahead and do this. So one other thing, I'm not sure if I did it for you all yet already or not. We can check, but if I haven't done so already, I intend to make a student version of the notes available where basically like this kind of information you can get it in advance. I just need to load it if it's not there. I think I did it for you guys. It should be on our Blackboard in that box link folder, right? So all of the stuff you see is already available. And I know I haven't been posting what I'm writing, but I intend to. And when I get it set up, basically you get anything that you see me writing, you'll get a copy of it at the end of each session. I just haven't set it up yet. But the link is there in Blackboard. It's the box link folder. Yeah. Okay. So I just need to go ahead and do that because you should be able to have a copy of this in advance. Okay. So So for part A, right, it says let f of x be 3 to the power of x minus 2, and they're asking us to find f of 4, right, when x is 4. I'm just going to kind of do it quickly. So if x were 4, that would be 4 minus 2 is 2. So then 3 squared would be 9, right? So for that one, we should get 9. Oh, they're all done? Okay, that's not what I wanted, but that's okay. Well, I'll just use this, all right? So then for for part B, we were looking at when x was -2, right? So it was -2 times 10 to the power of x. We replaced the x with -2. So then 10 to the power of -2, a negative exponent, it becomes a fraction like this, all right? Negative exponent moves it to the denominator. So then 10 squared is 100. So then that's basically 2 over 100, and you can write it like this, or -2 over 100. What is this? Let me go back, okay? So then this one, for part C, we're letting x be a -3/2. Let me think about that one. I really should give myself more space. I'm gonna just kind of write here a little bit. So if we have 1/9 to the power of a -3/2, so a fraction and the exponent, it really is really a radical, right? Let me see. Since 9 is a perfect square, let me see. I'm going to pass the negative, apply the negative. Let me think. Yeah. So the negative exponent means basically like 1 over 9 to the power of 3/2, right? It just moved to the denominator. Let me think. So then we can pass that exponent into the parentheses and we'll get something like 1 over 9 to the 3/2, right? So then we have a fraction within a fraction, so we can do keep, change, flip. Keep, change, flip. So then this will really just become 9 to the power of 3/2. And then what this means is that that denominator of 2 really just means square root. Now I'm going to do my square root first. I think this is okay. There might be something else I need to do there, but for right now, this is good enough. So the denominator being 2 means the square root of 9. And I did it this way because 9 is a perfect square. Let me think. Okay, so the square root of 9 is what, 3? And then 3 to the power of 3 is 27. All right. And then for part D, we would need to use a calculator. 4 to the power of x, where x is 3.2, we would just use a calculator there. Okay. So I think we did A and B already. And then let's see. So 1 over 9 to the power of a -3/2. So what they did, they rewrote the 1 over 9 as they worked backwards, right? I think we moved the negative. Instead, they rewrote the 1 over 9 is the same as 9 to the -1. So then 9 to the -1 to another negative, double negative becomes positive. And then now we did it from this part, and it's the same. I like this technique a little bit better. That's why I kind of paused. I couldn't think of it, but it makes sense, right? And then for the last one, we would just use a calculator to generate that. Okay. So that was just like a demo on evaluating exponentials. Let me go back and check Zoom really quickly. I think I can do it here. We got any stragglers? Oh, we got a lot of stragglers. Let me stop my screen share. These students. Okay, all right. Let me know P. This one. JK. Here he is. H. Right here. He has like 2 accounts. It's whatever. Okay. Yes. Okay. Huh. That's interesting. Okay. And then this student. If you're on the call, please try to include your last name, so I'm not like searching for your name. Make it easy for me to find your name. So I know I had another student. Still trying to figure out. Oh, there he is. So yeah. And then this one. There he is. So yeah, if you're on a call, just I encourage you to try to include your last name so to make it easy for me to find you. I got this student as well. Okay, that's fine. Okay, it's looking good. Let me go back to, let me check the chat. Oh, the chat looks good. Okay. So there don't seem to really be any questions. So let's keep going, start the broadcast. All right, so we worked through a few examples on evaluating exponentials. This one asks us to graph this function. So we have f of x equals 3 to the power x. So we're going to get a sense or see the general shape. There's a general shape for exponentials. Then, like from College Algebra 1, we can apply transformations to graph a lot of these, right? There are a few key points when it comes to exponentials, namely like when x is 0, when x is -1, and when x is 1. That gives you the general shape of the exponential, and then provided you account for any like transformations. So to graph this, all we're going to do, to introduce it, we chose several values of x. So we chose basically the integers from -3 to 3. And then we're just going to plug it in to find the corresponding y, right? So let's just, I think I'm going to just rely on my typed notes already, my prepared notes. So for instance, when x is -3, remember a negative exponent causes it to flip or become a fraction. So it becomes 1/3 to the 3. So that first one would be 1/27. Then it looks like it's 1/9, 1/3, and then 1, and then 3, 9, 27, right? Okay. So we chose these values of x on our own, and then these are the corresponding y's with those x values. And then we basically would just plot the points, right? So here's one ordered pair, another, just plot these ordered pairs. And so when you plot those ordered pairs, you get something like this, right? So the first one on the left is just us plotting those ordered pairs. And then if we connect those with a smooth curve, we get a shape like what we have on the right. And so the image that you see on the right here, this is the general shape of an exponential. It looks like that, where going off to -infinity, off to the left, it gets infinitesimally close to 0, but it's always above the x-axis. It never actually reaches 0. So exponential functions have what's called a horizontal asymptote, right? Where as we go, the further to -infinity that we go, the closer to the x-axis we get, but it never touches the x-axis. Without any manipulation, it doesn't touch the x-axis. And then going to the right, there's no vertical asymptote here, so it can always find any x going to the right, there's a corresponding y. It looks like it becomes vertical, but it doesn't. It just gets really steep really fast. But it's always, it's no vertical asymptote. It never gets cut off. Okay. So hopefully that was okay. That made sense. This is a graph for a typical exponential function when the base is 1. Right. So, and we'll explore some manipulations and things momentarily. So now let's look at an example where the base is not 1, namely between 0 and 1. Right. So here we let the base be a half, and we're essentially doing the same thing. We chose these values of x. We're going to find the corresponding y. And notice if we plug in when x is -3, right? So then we can do the same technique we did a moment ago, where if that exponent was -3, and we have that base of 1/2, we can rewrite that base as 2 to the -1, and then 2 to the -1 to the -3, double negative becomes positive. So it's really just 2 to the power of 3, which is 8, right? So this one is going to be 8, and then what? 4, 2, 1, 1/2, 1/8, and then, no, sorry, 1/4, and then 1/8, right? So it's here. So when x was -3, now if you need me to write that out, I can, but when x is -3, corresponding y is here, so on and so on. So to get a sense of this graph, right? So now we went from where the base was larger than 1 to where now the base is between 0 and 1. When that base was larger than 1, that was an example of what we call exponential growth, where as we move from the left to the right, the graph was growing, like our bank account's about to do, take off exponentially, just like that, boom, all right? There's so many ways to do it. I feel like I kind of want to say a little bit of philosophy, but I can't develop the idea all the way, so I'm not going to say it. So in the previous example, we saw an example on exponential growth. So with this one, instead of exponential growth, then you can anticipate exponential, what we call exponential decay, right? So when x was, for instance, if it was -4, I think this is like 16, I think, right? And then what is that one? 8, 4, 2, 1, so on and so on. All right. So this is an example of exponential decay when the base was between 0 and 1. With exponential decay, we start off really, really high, and then it decays rapidly. And then these are the three key points when x is -1, when x is 0, when x is 1. Notice it gives us the general shape, exponential decay. If we went to the previous, it would give us the general shape of exponential growth, right? We still have our horizontal asymptote. So the further off to the right or positive infinity we go, the closer the function gets to the x-axis, but it never reaches 0, all right? It never reaches 0, okay? Let me take a moment. I just want to check Zoom and check on you guys. Let me see. The chat looks good. We do have a straggler. Let me go ahead and get him. Got him, coach. There he is. Okay. And let me let him in. All right. So let's go on to the next one. So properties. So these are just some properties of exponential functions. Let f of x be an exponential function of the form a to the power of x, where the base is strictly positive and not equal to 1. The domain of the exponential is all reals, right? So for every x in our domain, there is a corresponding y. So every x is accounted for, right? So the domain is all reals. But the range, remember how we said the graph sits entirely above the x-axis? The range goes from 0 to infinity. Notice that the 0 has a parentheses, right? So parentheses, again, in this context means we get really, really close to 0, but it actually never reaches 0. It gets infinitesimally close. It looks like it's touching, but you have to understand the concept that it's not actually touching, right? If we don't move it up or down, it never touches 0. It just gets really, 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 really infinitesimally close to 0, almost like Ant-Man. Like if Ant-Man were to go microscopic, he'll show you the space between our function and the x-axis. Hey, thanks. Come here. Thank you. Thank you so much for alerting us to whoever is around. Thank you. That's our helper, Malachi. Hey. No, come here. Come here. Come on. You're distracted. Let's go. All right. She's just doing her job, what we pay her for, in the form of food and bones and things, to alert us of the comings and goings in the building. Okay. But she always likes, I guess people come and go while I stream, so then she just say, hey, she's like a second alarm or whatever. Let me see. Okay, so the graph lies entirely above the x-axis. Now, let me see. So say we would consider f of x plus 1 over f of x, right? So that's going to be a to the power of x plus 1 over a to the x. So then this, you can rewrite this guy as this. And so then this is basically a, right? So basically what this is saying is that as x increases by 1 unit, the y value increases by a factor of a, which whatever the base is, right? So every time we do 1 unit increase in x, the y value increases by a factor of whatever the base is. Thank you. Man, these 50-minute classes, they're so like short. You blink and it's over, right? Okay, so where the base is larger than 1, we call it the growth factor is a, because the y value increases by a factor of a for each unit in x. F is an increasing function, right? So this was an example of the exponential growth that we saw in the first one. So the graph rises as we go from the left to the right. As x goes off to the right, y goes to positive infinity. As x goes off to the left, y goes to 0, right? It doesn't actually reach it, but it approaches 0. And then when the base is between 0 and 1, this is like the second example we saw. That's called, that's the decay factor is a, or like exponential decay. For every unit increase in x, y decreases by a factor of a. All right. So then the exponential decay function is a decreasing function. So it falls as it moves from the left to the right. And, analogous things here, right? As x goes off to the far left, y goes to infinity. As x goes off to the far right, y approaches 0. Okay, each exponential function is 1-to-1, right? So I think 1.7 were inverse functions. So what that means is that each exponential function, if it's 1-to-1, that means it has an inverse. 1-to-1, having an inverse, and passing a horizontal line test, these things can be used interchangeably. So if you ever hear somebody say 1-to-1, you can switch that out with the phrase, it has an inverse. You can switch that out with the phrase, it passes the horizontal line test. So what that means, in order to show something is 1-to-1, if we consider two different y values, then we have to show that the x's are equal, right? So two different y's ending with the same x, just showing the x's are equal, then that's how we show that a function is 1-to-1. And this just means that the function has an inverse, right? So this is just like properties. I feel like this will become more clear once we start working through an example or two. We got a few more. The graph of an exponential function has no x-intercepts. Remember, it does not cross the x-axis. Again, it never crosses the x-axis. So no value of x will cause the y value to equal 0. All right. The graph of f of x is a smooth, continuous curve, and it passes through. These are the 3 key points, right? Basically, when x is -1, 0, and 1. We're almost done with this. I know this is a little bit hard to digest because it's just talking. Again, I feel like once we start working a few examples, it'll sink in, and it will become second nature through repetition. Because of our limited time and stuff like that, this is why I encourage you, like, the group me and you guys working together, linking up with the tutors. I try to use class time as a Q&A as much as possible, because we just don't have enough time to do everything we need to do when we're together. So we have to be working outside of class. Okay. From 4 and 5, we conclude that the x-axis is a horizontal asymptote for every exponential function of this form. The graph of y equals a to the negative x is reflected about the y-axis of the graph of the original, right? So when you have a to the negative x, if you think about transformations of functions, if we multiply the inside by a negative, that's going to flip it horizontally over our y. And so then we go from exponential growth to exponential decay. Okay. I kind of wish I had done my story. I just enjoy the story. It's interesting, but I feel like it's a bit much. We don't have the time. Okay. So we have this definition on the interest rate is the percent charge for the use of the principal for a given period. The interest rate denoted by R is expressed as a decimal. Unless stated otherwise, the period is assumed to be 1 year. That is, R is an annual rate. The amount of interest computed only on the principal is called simple interest, right? So that's the lowest form of interest that we have, is simple interest. If you have a formula sheet, it is a good idea to include this formula on your formula sheet. It's a simple interest formula. So the simple interest I on a principal P at a rate R expressed as a decimal per year for T years is given by this. I equals PRT, right? So it's the principal times the rate times the time. This is simple interest. It's the lowest form of interest that we have, right? So Juanita has deposited $8,000 into a bank for 5 years, a simple interest rate of 6%. Part A asks, how much interest will she receive? And then part B asks, how much money will be in her account at the end of 5 years? Okay. We got a solid 15 minutes. Let's get into it. All right. So how much interest does she receive? So we can use a simple interest formula. One of my professors would say every time we use a formula, it's a good idea to write it down. So simple interest, I equals PRT, right? Let's see. We can identify the components. The interest, that's what we're solving for. The principal. So the principal is her starting amount. So that's going to be here. 5 years, so our T is 5 years. It's there. And the rate, we got to convert that rate. It has to be in the decimal, right? So that's the information. So if we plug in the information, again, it has to be in the proper form. Our interest is going to be the principal, which is our $8,000. The rate, we have to convert the rate to a decimal. So 6%, you can look at, anybody got a favorite color? We got a favorite color? you can look at this percent symbol as it meaning per 100, right? So that percent symbol, you can look at it as 1 over 100, right? So in other words, it's like dividing by 100 or move the decimal to the left by 2. So what that means, 6% as a decimal is going to be 0.06. And the time in years, it says it's 5, right? So then you crunch that number. Let's see. Hey Siri, what's 8,000 times 0.06 times 5? Okay. Hey Siri, change your volume to 80%.
Okay.
Whoa.
This is as loud as it gets.
Whoa. That I said 80, right? Let me see. Hey Siri, change your volume to 70%.
I'll speak softer.
That's fine. Okay, right? So that was the interest that we got for the first part. Okay, and then for part B, it says how much money will be in her account. So then for part B, if we want her future amount, that's going to be her starting amount plus the interest earned, right? So then it's just going to be the 8,000 plus the 2,400 equals 10,400. Is that reasonable? Yeah, 5 years. Yeah. Let's copy. Let me get rid of this and paste. And like that. Okay. So we got 2,400 and then 10,400. So you see the 2,400 here, right? And then for part B, 10,400. Okay. So hopefully we're all aboard and we're not all bored. I know it's like, I know how much is drones. It's not long, it's only 50 minutes, right? So I think that's a plus, you know. And this course is actually, you know, it was broken in half. This is like the second half, like what you all are required to do right now in College Algebra 1 and College Algebra 2. In the past, that was all just one semester. And I mean, students got through it, but it was intense. It was intense for everybody, you know. So just know that it could be worse, you know. Let's just try to, you know, appreciate the 50 minutes that we have, do what we need to do, keep our minds clear, keep our morale high, focus, and follow through, right? Let's just knock it out and move on with our lives. All right. So we can prosper and, you know, progress and become these beautiful, radiant beings that I know that we all are, right? We got a solid 10 minutes, so let's take advantage of it. We have a few definitions. We have compound interest is the interest paid on both the principal and the accrued previously earned interest. Interest that is compounded annually is paid once a year. For interest that is compounded annually, the amount A in the account after 2 years is given by this. All right. I would say just ignore this one for right now. I mean, we are going to work an example. There's another formula, the compound interest formula that's coming up. This is omitting, like this is if the interest is compounded once per year. If you're only applying the interest once per year, right? It looks like this. You can omit this one because there's another one that's coming up that's more accurate for compound interest. I think we do have an example that corresponds to that. We have that Juanita deposits $8,000 into a bank at an interest rate of 6% compounded annually for 5 years. How much money will she have in her account after 5 years? How much interest, right? So I think we're using that compound interest formula that we just saw on the previous slide. So I'm going to kind of write it right here. Let me see. It should be 1 plus n to the power like this, right? Because the interest is applied once per year, so we're using this formula. If it says how much money will she have in her account after 5 years, so we want to find the future amount, right? We want to find this future amount. Okay. So for part A, the future amount after 5 years is going to be, now she's starting with $8,000. 1 plus the rate as a decimal. So if it's 6% as a decimal is 0.06. and the time is 5 years. So again, this is when the interest is applied once per year. Then we use a calculator. Okay, I'm gonna do the following. There it is. Oh, come on. Hang on. Sorry. Right back. There. Nope, that's the wrong one. No, go away. How do I just go away? Okay, let's try it. What I'm trying to get is this one. There we go. All right. So yeah, anyway, reload and refresh. Okay, that looks good. Okay, so let's just see how basically we can type it in the calculator. This is a TI-83 Plus emulator. It's free, but it takes finagling to like get it set up. This is a emulator that was created at another school somewhere. I discovered it. I had looked for it for years. I eventually found it, and I've been using it for years. Right. So 1 plus 0.06, and then to the power of 5. Right. I think for what we're doing, this will suffice. So then we get 10,705. Let me see if I go here. Boom, like that. We get approximately $10,705.80. Right, if we just use conventional rounding. Can I paste? Awesome sauce. Okay. And then how much interest will she receive? So then if this is a future amount, let me see. So a moment ago, we said the future amount was the principal plus the interest. So if we want to calculate the interest, so for part B, her interest earned after the 5 years, we said it was principal plus interest. So then it's going to be the future amount minus the principal, right? So it's going to be the future amount after 5 years minus the principal, right? So then,
Professor.
go ahead.
I said I don't think I can see your screen, Professor.
Oh, okay. Yeah, probably when I turned it off, it lost my screen. Let me check this real quick. That looks good. Thank you for giving me the heads up. Share the screen. Here it is. Start the broadcast. I'm not sure what you guys missed. I don't think you missed much, so I'll let this be. So then basically it's going to be that 10,000 minus 8,000. So I'm just going to kind of write it shorthand because I'm running out of space. I'm just going to say minus the 8,000. Right? And we get, what is that, 2,000. So 2,705. I was at 5 years. I mean, that's not a lot of money, but it's for these kind of examples, this is like a precursor. Even though that's not a lot of money, but it's the way she earned the money. She was out living her life, right? And this is just the beginning. It'll grow very quickly. Like if she has an account earned, I wish I had an interest-bearing account that earned, what's the interest? 6%? Oh man. Because like once you get to certain levels with interest-bearing accounts, okay. Even though I'm not doing the other story I did, I'm going to go ahead and take a moment. I do want to share this experience that I had. And I do like to title this experience. It's really simple and short. It was basically what's called the Infinite Scholarship, right? So when I was a student at Morehouse, I was part of an honor society. I forget which one it was, but we were having a meeting and they were doing a fundraiser for this thing called the Infinite Scholarship, right? And so the setup was that they had an interest-bearing account that earned 5% interest. Oops. 5% interest, and they were trying to raise $1 million. Right? So this is the lowest form of interest, simple interest. So if we just consider simple interest, I equals PRT, right? So how much money, if you had $1 million and it was in an interest-bearing account to earn 5% a year, how much do you earn a year, right? So if the principal is 1 million, right? And the rate is 5%, and the time is 1 year. How much money is that a year? Can somebody tell me that one? How much is that a year? So another thing that we can do, if we're just multiplying, right? We have what, six zeros? I think we can just move this decimal to the right 6 times, right? So let's see, 1, 2. So let me see, 1, 2, 3, 4, 5, 6. So on a yearly basis, the interest earned is $50,000 a year. That's basically a full-time check. So, and I mean, I know people, and I intend to be one. I'm not one yet, but I know people that's had this amount of money. They gave it away, right? I wouldn't have done that, but instead of giving it away, I would have set something up like I would have set something like this up, because when you have that something like that, then these start to become available. All right, then banks kind of treat you differently, and they'll start to offer accounts that behave in this way. So then basically the bank will be paying you a full-time check just to have this set up, right? And so what that means, the reason it's called the infinite scholarship is because as long as you don't spend more than the principal, this could be easily like a couple of $1,000s a month, right? Think about it. If it were $2,000, if you only spent $2,000 a month, say it was 10 months, okay, 10 times 2 is 20,000. So you can spend what, 4,000 a month? 40. So 4 times 12 is what, 48, right? So if you like omit like taxes and other things, this is like anywhere from $3,000 to $4,000 a month, right? That's more than enough to live off of in today's standards, give or take, right? But again, with that set up, this principal with this rate, and so basically they have money like $4,000 coming in a month, and they don't have to punch a clock. They don't have to show up anywhere. They don't have to. Sorry, but we won't have to like do anything but what we want to do. Now, I know people that actually are able to do this. Another example where I've experienced this, not directly, but through stories of people I know, like so this group that I'm a part of, one of the members was saying that his father left them in this apartment complex, where with this apartment complex, it generates like $20,000 a month, but it's linked to property managers. So like the property manager manages the property, but as the owners, they just collect $20,000 a month and they don't have to do anything. They don't have to punch a clock or anything like that. To me, I totally resonate with that way of making money. I never really encourage anybody to trade time for money, unless it's something that you love to do and you get like joy out of doing the task itself. But if you don't love to do that thing 24/7, I again, I'm no financial guru. You gotta like do your own research. You gotta network and things of that nature. These are just stories that I've come across that like I intend to bring to life. Right, I fully intend to do that. Right. So that was just the story on the infinite scholarship, basically using compound interest. And when you're aware of stuff like this, once you're able to do it once, then you can do it again. Then now you're talking about assets, and these are things that you can give to your loved ones that they can. The stipulation is do not spend more than the interest earned, right? As long as you don't spend more than interest earned, that's like $3,000 to $4,000 or a little bit more coming in every month, right? For doing nothing, just for having the account set up. One other way that I've seen this is on a lower scale. With there are certain like stocks and companies that will pay you to own some of their stock, and this is called like dividend stock. So this is another example of like passive income. Obviously, we don't all have $1 million with this kind of account, but we can like purchase dividend stocks where they will pay you a portion of like their profit. They will pay you to just have money, own some of their stock, right? And so that's another way to just have money coming in, right? Passive. So anyway, with that, I went on and did that because I saw we had about 5 minutes before I like to stop. So that's why we did the story. That is a good stopping point. There's obviously, we made it about halfway through this lecture. The full lecture is available on my YouTube. I do encourage you to go there, watch it, take notes if you're in class. Now, all the stuff that you see me writing, I think I've made the student notes already available. I intend to do that for all of my classes. And then once I make the students' notes available, whatever you see me writing on any given day, I'm going to load it into a link where you can actually pull the file. I just haven't set it up. I've been intending to do it since the beginning, but we'll get it set up. Are there any burning questions? Let me kind of go check the chat. I think the chat looks good. Did you guys have
I have a question.
any burning questions? Go ahead. Yes.
Okay, my question was for the for the code. Do we have to? Because I've been using it for free, the little free trial thing, but my trial is almost up. So for us to get the code, we'll have to pay for it first.
Yeah. Yeah, you want to try to pay for it before you have to pay for it. Even if it ends, it'll save your work, but then you won't be able to access it until you purchase the full access.
Okay, so
You don't want to be
link
locked. Okay, so I think his question got answered. Yeah. So, are there any other questions, comments, or concerns?
Yeah, I had a question. When I was looking at my grades, it said I had like a 60 for attendance. You know why it gave me that?
What's your last name?
Gordon.
All right, say that one more time.
Gordon.
That would have happened. Did you miss a day?
There was one day when the Zoom wasn't working. I mean, when it said there was no class for me. Like it said, nobody started a meeting.
Yeah, we've been meeting every day. You said Gordon?
Yes.
Yeah, I remember that day. Yeah, we met. You just gotta. Yeah, I'm not really sure, but we've been meeting each day. But don't worry too much about it. Today, delete this meeting. Don't worry too much about it. Just the main thing is that you showing up, and getting your assignment submitted. It really only becomes a trouble like if you get booted from the course, right? Just try to don't stress too much about it. It doesn't get factored into your grade at all. It's really just a record keeping. If you've been like showing up and you've gotten your stuff submitted, I'm sure we can get past that, right?
Okay.
But yeah, but just you don't want to rack up a whole bunch of excuses. For right now, it should be okay. Okay. Yeah, and so
another question after that.
Yeah, you had another one.
How many questions was the midterm going to be?
So we haven't. Exam 1 has not been posted yet. It'll be available this upcoming Sunday at 11:11 in the morning, and it'll be available to maximize your points. That will be available for 7 days, and then it'll lock out. Basically the following Sunday at 11:59 p.m. But you can work on it past the due date with only a 10% late penalty. All of our assignments are unlimited attempts. The system is going to take your highest score, and you can work on any assignment past the due date with only a 10% late penalty. The hard deadline for all assignments is the end of the week of finals, that Friday at the end of finals. That's when everything locks out because we have to calculate grades and things of that nature.
Okay. Sounds good.
Other questions, comments, and concerns? Okay. So if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. All right, guys, take care. Peace.
Good, Professor.
Yeah.